Okay, hi guys. Today we are going to do a little bit reverse on systems of inequalities. Yesterday we were given the inequalities and we had to create the graph. Well, today we are going to be given the graph of inequalities and we have to create the system. So let's look at the first one here we have on the left. We have two lines, one's solid, one's dotted. Let's go ahead and look at the dotted line first. Well, if we're going to write the equation of that straight line, it is linear, so I can put it in slope-intercept form. So what I'm going to do is determine my slope and my intercept, and I'm going to be able to make an equation that way, hopefully. So if we look at this dotted line, and if we can find two distinct points, we can determine the slope and the y-intercept. Okay, now this dotted line looks like there is a, well, I was having trouble trying to find a distinct point, but look at how the axes are labeled. Every line is going by twos. Okay, so it's not going by ones. All right, so let's look at this point here. It's because it's kind of halfway on the y-intercept between these 2 points. So if I'm going by twos, this would be 4, 6, 8. Well, it appears that my y-intercept for the dotted line is going to be 7. And let's go ahead and find the slope. I see this point here of intersection, and it looks halfway in between 2 and 4. So my slope between here and here, well, if every whole step is 2, then every half step is worth 1. So this would be 1, 2, 3, positive 4 over 1, 2 in the positive direction. So my slope is rise 4, run 2, which is 2. So I could say that the equation of this line is going to be y. Now I'm not going to put equals, and since it's dotted, I'm going to have to figure out whether it's a less than or greater than sign. But I do know that it's going to be y, some kind of sign, mx plus b. Now if we notice this, if we were thinking about just this line, everything up here is shaded, which means the side where the origin 0, 0 is not shaded. So in other words, 0, 0 would not be the solution. If I were to put a 0 in here and a 0 in here, I want to create a not true statement since 0, 0 is not shaded. Well, if I'm going to compare 0 and 7, the true statement would be 0 is less than 7. But since I don't want it to be true, I'm shading the other side. That means it has to be greater. That's not true. That means this side of the dotted line is shaded. Okay, let's look at the other line here. And remember, we're going by twos on each one of these lines on the coordinate grid. So here's a distinct point, and I would say my y-intercept here is -1. And let's go ahead and use this point again. So it looks like my slope is going to be down 1, 2, 3, 4. And I'm going to run 1, 2 in the positive direction. So my slope is -2. Okay, so let's create the equation for this line. It's going to be y, and since my line is solid, it is going to include the line, but I have to determine greater or less, and I'm going to do that later. So y is partially equal to -2x minus 1. Okay, now if we look at this line, the shading of this line is over here, which means, again, the 0, 0 is not shaded. So that means I need to come up with some kind of an inequality where 0, 0 would not be true. So here I have, if y is 0 and -2 times 0 minus 1, I'd have 0, and this would just be 0 minus 1. And I'm going to compare 0 and -1. Well, 0 is greater than -1. But remember, I don't want a true statement because I did not shade where the origin was. So I'm going to make this less, and that's not true. So my inequality system would be y is less than or equal to negative 2x minus 1. Here are my two systems. Okay, let's look at number 2, or the second one. Notice that we have parallel lines, so my slopes should be the same, but my y-intercepts are different. But look at the shading. So the solution to this system would be everything in between the lines. Let's look at this top line. My slope for my top line is down 1, right 2. So that's negative 1 over 2. And the y-intercept is 3. And I notice that my axis here is labeled by 1s. Okay, so y, and if I'm looking at this line, this side of the line is shaded. That means the 0, 0 is shaded. So I'm going to create a true statement. So y, with some comparison, mx plus b. Well, since the line is solid, I will have that equal part. Let's put in a test point 0, 0. If y is 0, x is 0. And again, since y and x are in the shaded region for 0, 0, the test point, I need to make a true statement. 0 and 3. Well, 0 is less than 3, and that does make a true statement, which would allow us to say that this side is shaded. So this first line at the top, y is less than or equal to 1/2 x plus 3. I'm sorry, negative. Okay, now my second line, well, the lines are parallel, but I can also check the slope if I wanted to. Down 1, right 2. It's negative 1/2, so they're parallel. And my y-intercept is negative 2. Now this time, when we're looking at this line, the origin is above the line. So 0, 0 is up here. So I'm going to have to make a true statement with this inequality. So I have a y, and this is also going to be negative 1/2 x, but minus 2. So let's go ahead and put in the origin, 0, 0. So if I have zeros and then negative 1/2 times 0 minus 2, and I want to create a true statement, well, this would be 0, this would be negative 2, and to make that true, 0 is greater. So this inequality, y has to be greater than, solid line, or equal to. Okay, now the last example over here, both our lines are dotted. So we're not going to have this equal to line like we had over here in the previous example. So the first one, let's look at this one going this way. My slope is, and look at your lines, they're numbered by 1s. So it's going to go down 1, right 2. So it's negative 1/2 again. And this top line, this y-intercept is 4. So I have y. I've got to figure out my comparison, negative 1/2 x plus 4. If I were just looking at this line, everything below it is shaded. So 0, 0 is a true solution. So I'm going to put in 0 and 0, and I'm going to make a true statement. This would be 0 plus 4, which is 4. So to make this true, 0 is less than 4. So in my inequality, this would just be less because it's dotted. Okay, let's look at this last one right here. Look at the slope. My slope goes from here. I can use that point, and this looks like a distinct point. So it looks like it's rising 1, 2, 3, 4, and running 2. So 4 over 2 is 2. And the y-intercept is 1. So y, and I'm going to have 2x plus 1 on the other side of the equal sign. Well, let's try to figure out what part of this is the solution. To the right, we have everything shaded. The 0, 0 is in the solution's shaded region. So let's put in 0 for y and 0 for x and make a true statement. 0, and this is 0 plus 1, which is 1. So to make this true, 0 is less than 1. So in my inequality, y is less than 2x plus 1. Okay, so if you have any questions, please come ask. or replay the video and watch it again. And I would like for you to go ahead and try the bottom 3 at the bottom of this worksheet.